Stream. And we're here. Oh, let's see. Can I just not this? Not this. Okay. So let's see. Let's do like this. So we're gonna monitor the chat. No real announcements. We are in week. I think it's week 11. So like we're gonna wrap up section 2.3, dividing polynomials, synthetic division, and the rational zero test. And then so after 2.3, next week we have exam 3. Give me a moment, I'll be right back. So yeah, we have exam 3. Let me see. Just whatever the next sequence is. If this is chapter 2, I think it's over chapter 2. So 2.1, 2.2, and 2.3, right? And then after that, we have 3.1 and 6.4. We only have 2 sections after that. So we have about 3 to 4 weeks remaining. We have time for an exam, a couple of more sections, and then a final exam, right? So we're going to be done pretty quick. So I say that to say, now's a good time to get current or get caught up on Pearson. As we get closer and closer to the final, Pearson's server is going to get slower and slower and more unreliable. So the best thing is to go ahead and get caught up as soon as possible. So as we get down to that crunch time, it won't be as much of an issue. This is strange. This isn't okay. All right. So we're just going to take some time and go ahead and finish out section 2.3. And then the rhythm that we'll kind of have with each week, because we do have a lot of downtime, we have a lot of extra time. We'll use that time. Give me just a moment. Where's Mr. One Shot? He's missing his shot. Okay. Admit. Okay. Yeah, so we'll probably start reviewing some factoring. This chapter that we have on factoring, we'll probably start reviewing that today. We'll do the lecture for today, and then Thursday, we'll take that day to go through the homework for this section. Once we finish the lecture, then that's a good time to ask questions on the homework. So if anything wasn't clear, or if you need help with any homework assignment, during class time is a good time, especially towards the end of the week, right? But once we finish a lecture, then that's the best time to kind of ask those kind of questions. If you want me to go over your question specifically, you have to make use of the Ask My Instructor tool. You click on that, it'll send me a screenshot of your question. You type your question, like whatever trouble you were having with the question, and then we can either talk about it during class or I'll make a dedicated YouTube video. Are you jumpy? It feels good here. What's going on? Why are you behaving like that? I think you need to be rebooted. Alright, let's see who's gonna come in here. James. So I finally watched this movie I have been wanting to see since I saw the trailer when it was in theaters. I watched it like throughout the night. It was a movie called what's it called? Ready or Not. It's on HBO Max. I was like, I don't want to spoil it for anybody, but it was a silly movie to be. It was just silly, and it caught my attention because when I thought it was in theaters, we went to see this movie called Knives Out, and I was like, this is not the movie I was thinking of. Even though Knives Out was good, um, but those are two different movies that are similar. You have Knives Out and Ready or Not. But yeah, they kind of came out, and it's weird. Hollywood has this tendency to do that. Like they'll release movies that are similar simultaneously. Like they did the same thing with Deep Impact and Armageddon with like Bruce Willis and whoever's the Deep Impact crew. They did it with The Illusionist and I forget the other movie. It's with Hugh Jackman. I think it's called The Magician, something like that. But there are several like movies that were the same. It just was released by two different people. I don't know what that's about. That's kind of weird to me. But yeah, so let's take some time to go ahead and finish out. That's coming. I'm trying to wait for my girlfriend. Like I'm trying to wait. I'm really trying to wait for her. Like I keep getting ready to watch Lovecraft Country because I've had people tell me about it. They say it's good. So I'm trying to. We're supposed to start that soon. So we'll start. But I'm gonna try to get caught up on all the HBO stuff. So like what's it called? Westworld or something. I was gonna watch that one. It's a bunch of them on HBO. I was gonna get caught up on that I've been intending to watch. It just takes a lot. It takes a lot for me to watch a series because I don't want to give my attention away. Like that seems it's just so draining, to keep up with the story, focus my eyes. Like I don't want to do all that. Like honestly, if I could just listen, I would probably be a lot happier. Like a story, radio story. That's funny. Nobody does that now. Like it's a story, but it's only audio. They don't do that anymore. But I think there's a venue there because, like, I like to just listen to stuff. Like sometimes I just want to close my eyes. You know, to have to focus my eyes all the time is so draining. Like I'm like, yo, leave me alone. Anyway, all right. So let me see. I think this is correct. Okay. So we're going to start with this example. So I think in this section we were exploring polynomial long division, synthetic division, and things of that nature. So we have this example. It says the combined petroleum consumption in quads by a group of the most economically developed countries in the world from 96 to 2011 can be modeled by this function. Where x equals 0 is 1996, x equals 1 is 1997, and so on. The model indicates that C of 5, 238 quads of petroleum were consumed. So when x is 5, that's the year 2001. All right? So then we're asked to find another year between 2001 and 2011 where we consume 238 quads of petroleum. Okay, let's see. So I finally figured out how to keep updating my attendance without disrupting the note taker app. In the past, I was switching the app, and it would just it was a whole long drawn out process. Let me see. I think he was already in here. Let me see. There he is. Okay. And then this one. Go like this. All right, that looks good. We got the 3. We can let him in. Yeah, I just let him in. Thanks. Yeah, that's what I was doing. I just let him in. Thank you for that. All right. So again, it says when x is 5, that's the year 2001. It indicates that 238 quads of petroleum were used, right? So then we're asked to find another year between 2001 and 2011 where we consume 238 quads of petroleum. Okay, so let's do this. Let's give ourselves some space. We're going to add a page. If you have seen Ready or Not and you enjoyed it, no, they're not the same. Ready or Not and Knives Out, but I enjoyed Knives Out. It's a little bit slow, but if you can get a copy or whatever, it's worth a watch at least once. But it is a little slow to kind of forewarn you. Let's go here to paper this. And then we need to do this. Review, seamless, and then guys keep trickling in. I'm trying to stay like not upset, trying to stay chill. I hadn't really been, doing the late. As long as you kind of check in, that's the main thing. I've been trying to like be chill about it, but it's okay. Jalen Turner. I did not mean to just say your name like that. I was just reading out loud. It's okay. Let's let a man go like this. Okay. All right. So we're given that when x is 5, that gives us 238. We want to find another year from 2001 to 2011 where we consume 238 quads of petroleum. Okay. So let's take this function that we're given. We're given that c of x equals 0.021 x cubed minus 0.973. We gotta clean that up. 973 x squared plus 11.347. There's a typo here. X is missing from here. Plus 202.965. We want to set that equal to 238. And we already know that x equals 5 is one of those solutions, right? Let me shrink this down and get this onto one line. I'm just going to reorganize it. So this, I want this over here. Okay. Expand it back. Okay, let's go, right? So if we want to solve this equation, let's set it equal to 0. We're going to have 0.021 x cubed minus 0.9, for some reason I am not writing my sevens, x squared plus 11.347 x. We need to set it to 0. Hey Siri, what's 202.965 minus 238?
202.965 minus 238 is negative 35.035.
All right, so if we subtract 238 from both sides, we get that negative 35.035 equals 0. Okay. So now we're given that x equals 5 is equal to 238. So now if we plug x equals 5 into this line here, this line, then it should be one of our zeros, right? So let's confirm that 5 is indeed one of our zeros. So what we're going to do, we're going to use synthetic division. If we put 5 in the chair, notice our exponents. They go 3, 2, 1, power of 0. So our exponents are good. So every exponent is accounted for. So we can take all the coefficients. We're going to have 0.021. We got this negative 0.973. We got this 11.347. We got this negative 35.035. Okay. So then this comes down. So if we do synthetic division, again, we should get a remainder of 0. We have the 0.021. On the diagonal, we multiply. Hey Siri, what's 5 times 0.021?
5 times 0.021 is 0.105.
105. Hey Siri, what's that answer minus 0.973?
0.105 minus 0.973 is negative 0.868.
Hey Siri, what's that answer times 5?
Negative 0.868 times 5 is negative 4.34.
Hey Siri, what's that answer plus 11.347?
Negative 4.34 plus 11.347 is 7.007.
Okay. So again, with synthetic division, whenever we go vertical, we add. Whenever we go diagonal, we multiply. Answer goes here. We add, then we multiply. So again, whenever we go vertical, we add. Whenever we go diagonal, we multiply. the last number when we do synthetic division is our remainder. If we have a remainder of 0, that means that this number here is one of our zeros, right? So we confirm that 5 is a 0 of this polynomial, right? So then, if we started with the degree 3 polynomial, at this stage we have a degree 2. So this is going to be x squared, this is going to be x, and we have that, right? So we want to factor this quadratic. To me, the simplest way to factor this quadratic would be quadratic formula, right? Quadratic formula goes as follows. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2a, right? Okay. So then if we plug in the corresponding components, negative b is going to be just 0.868 plus or minus the square root of 0.868 quantity squared minus 4. Our a is 0.021. Our c is 7.007. I'm taking the square root of all of that. Divided by 2a, so 2 times 0.021, right? Okay, so I'm going to put this in my graphing calculator. I'm going to do it a little bit differently than the way I've been doing it in the past, right? So in my graphing calculator, I'm going to do the following, right? I'm going to store my a, b, and c, right? So the first one is 0.021. I want to store that as my a. Okay. Then I have this negative 0.8688. I'm going to store that as my alpha b. Okay. Then I have this 7.007. I want to store that as my alpha c. Right. So I stored my a, my b, and my c. I think we're okay. Okay. So then I'm just going to type in the blue line for my quadratic formula, right? So I'm going to do negative b, let's do like this, parentheses, negative b minus the square root b squared minus 4. Let me see if I just put a, let me put my times in there because sometimes it don't act right if you don't put the operation in there. Times my c, negative b minus square. Okay, this is going to close off the square root. This closes off the top. We're going to say divided by 2a, 2 times alpha a. Okay, because we stored our a, b, and c, we can type it in like this. Let me see. We get that is correct, and then instead of minus, we want to do the next one as plus. Okay. So again, the way we did it this time, we stored, and again, store is in the bottom left-hand corner, just above the power button, the on button. We stored the a, b, and c, and then just typed the quadratic formula directly. And then, you know, I feel like it's a little bit easier to see, right? Okay. So then again, when we solve the quadratic formula, we get x equals 11 or 30.3 bar. But then the question asks us to find the year between 2001 and 2011. X equals 11 is going to be what? 2007. And that is between 2001 and 2011. 30 is too far. So we got 2007 for this one. I know why I got the sniffles now. Whenever I eat any kind of like animal product, especially if it's cheese, all this mucus just starts pouring out of my body. And it's like my body's like, hey, get that out of here. So it's like I constantly have to blow my nose and like just spit, like to get the mucus out. I'm mostly vegetarian and vegan. I definitely still eat meat, but most of the time it's vegan and vegetarian. But whenever I do eat meat, it don't matter what time of the year it is, I get like instant flu-like symptoms and a lot of mucus. I'm kind of using it. It's a philosophy by Dr. Sebi. He was like, basically, if you're trying to heal the body, get rid of the mucus. And if you want to get rid of the mucus, mucus comes from the animal products. That's just what I'm doing personally. I'm no nutritionist, but you know, that's what I'm doing. So that's why I have like all of this going on right now. So I'm just trying to flush my body of that stuff, and then it'll go back to normal. Okay. So we said 2007. So we did quadratic formula. We got the 11 or the 30.3, but we wanted something between 5 and 15. So that's the 11, which is 2007. Okay. Let me check the time really quickly. I have the chills. I got mucus chills. I'm turn the fan off. That might help. Okay, let's keep going. So next we have this this thing called the rational zero test. Okay, so the rational zero test says if given a polynomial function with integer coefficients where the leading coefficient is not 0 and the constant term is not 0, and p over q is a rational number in lowest terms, this is 0 of the function, then p is going to be a factor of the constant term and q is going to be a factor of the leading coefficient. So with the rational zero test, we're going to take all the factors of the constant divided by all the factors of the leading coefficient. We're going to do all the combos of those factors that we can. And if the original polynomial has rational zeros, it's going to be somewhere in the list that we generate. Right? That's the rational zero test. So let's see it in action. We're asked to find all the rational zeros of this. Right? So the rational zero test goes like this. We have our p over q, right? P comes from the factors of our constant term. So that's going to come from the 3. The factors of the negative 3, plus or minus 1, and plus or minus 3. The factors of the 2 are plus or minus 1 and plus or minus 2. Those are all the factors of 1 and 3, right? I mean, 1 and 3 and 2. So then what we want to do all combinations with everything on top divided by each thing on bottom, right? So I'm going to say everything on top divided by 1 gives me plus or minus 1, plus or minus 3. Then I want to say everything on top divided by 2 gives me plus or minus a half, and then plus or minus 3 halves. Okay? So these are all the combinations from the constant term divided by the leading coefficient. So what we're saying is that if this polynomial has irrational zeros, it's going to be somewhere in this list. Okay? So what we're going to do synthetic division on these zeros to see can we find one. So we're just going to start with, we're going to test 1 to see if it's a 0. Okay? So if we do synthetic division, notice the exponents go 3, 2, 1, 0. So we're clear on the exponent, so we're okay to go there. So then we say 2, 5, negative 4, and negative 3. Remember, the first term just comes down. 1 times 2 is 2. 5 plus 2 is 7. Times 1 is 7. Plus negative 4 is 3. 3. So fortunately we found our first 0. Right? So x equals 1 is a 0. So let's write out what we have. If we started with the degree 3 polynomial, now after the depressed equation, this is now a degree 2. Right? So we have this. So we want to find a 0 from there. We could just factor that. We're looking for two numbers that multiply to give us 6 and add to give us 7. That's going to be 1 and 6. Right? Okay, so what we're going to do, we're going to rewrite this 7x using what? 1 and 6. Again, I'm doing the AC method of factoring and trinomial. Let me see the time. Oh no, we just go. This is one of our longer days. Okay. So at this stage, we have x minus 1. And then we want to factor this. We have this 2x squared. Now that 7x, we rewrote it as plus 1x and then plus 6x. And then we're going to say plus 3 equals 0. Right? Okay, so I'm going to use factor by grouping. If I group the first two, I ask myself, what do they have in common? Oh, we can factor out an x from both of those, right? So the x minus 1 comes down. If we factor out an x from each one, we're going to be left with 2x plus 1, right? So when I'm doing factoring by grouping, I'm anticipating another 2x plus 1. So I usually just go ahead and write it, and usually it works. Sometimes it doesn't. Okay, what can we factor out of the second two? We can factor out 3, right? So now we have what's called a common binomial factor, right? So, it's like reverse distributing, right? So then if we lay all this out, we have x minus 1 we have this x minus 1, we have this 2x plus 1, and we're left with x plus 3 equals 0. Okay, if we apply the zero factor property, when things multiply to give us 0, basically set each thing to 0 and solve, we'll get x equals 1. That looks like a negative 1/2 and a negative 3. Okay, let's go like this. Okay, looks good. I'm just gonna get this effect out there. Okay, keep in mind I am monitoring the chat, so if you have questions, feel free to type it there. So now, if these are the zeros, notice that these zeros are indeed in that list. Let's check and confirm that these are indeed zeros. All right. So I'm going to clear all this. I'm going to go to my y equals. I'm going to type in the original 2x to the power of 3 plus 5x squared minus 4x minus 3. Okay. Let's see. Okay. So then we want to test these numbers. So I'm going to go to the left of the clear button is the VARS variables. I'm going to click there. I'm going to go to the right to go to y variables. We'll click on number 1 for function and number 1 to call the function that we just typed in. So now when x is 1, the answer should be 0. When x is a negative 1/2, the answer should be 0. And when x is negative 3. We should get 0. Okay? So we confirm that these three numbers are indeed zeros of the original. We definitely need some practice there. We'll get some practice with this homework on a Thursday. Let's kind of see what else we have. So that was just one demo on, let me see. So the first part, so again, the rational zero test says, if we take all the factors of the constant term, that's where the top came from, divided by all the factors of the leading coefficient, that's where this comes from. And then we want to do all combinations with everything on top, with everything on bottom, right? So I said everything on top divided by 1, that's where these two came from. Then I did everything on top divided by 2, that's where these two came from. Okay. So what we're saying is that if this original polynomial has a rational 0, it's somewhere in this list. Notice the zeros that we found. They are in this list. Yep, no worries. Number 1, let me see. Number 1 in the homework for this week. Sure. Did you, Mr. Rance, did you make use of the axiomatic structure? Make use of the axiomatic structure and I'll pull it up. Okay, so this is an explanation, like a typed up version of what we just did. Then we did synthetic division. Fortunately, we got lucky that 1 was a 0. So then finding that first 0 is usually the hardest part. And then I think we got the same results. Let me go ahead and add this homework to this. So let me see if I do the following. Okay. Let me go check here. Here. Give me just a moment, guys. I'll be right with you. This is black water. Let me see if that came in. Okay. Virtual tutoring, physics courses and labs, physics, computer science. I guess it's all the same. Contact. Okay, let me share this with you guys. Computer programming. This is all physics though. Computer. Okay, let's just share this anyway. So let me copy. Paste. Share. Add to this note. So there's that one. I'm adding this to today's notes. It's just something I just noticed in my email. There's that one, and then we have this other one. I want to share notability. Add to this note. Import. So, because I know that some students were looking for the tutors, so this is a great place to start. Because these say physics and computer science. I don't see the ones for mathematics just yet, but that's a great place to start if you're looking for a tutor. Okay. So either that one or this one. I don't see where someone requested. So let me see if I can pull up the question. I was trying to give the time for, I was looking for the Ask My Instructor, but let me go ahead and do this now. Let's go to Pearson. Nope, that's not right. Allow. Sign in. Not that one. This one. the time? Okay. Let's see. Where are we? College algebra. This one. And so there was a request for number 1 from this week. I'm just pulling it up. So again, like if you had used X my instructor, it'll have the exact same numbers as you. But if I pull it up myself, it's going to give me the same question with a different set of numbers. So yeah, again, this is a snapshot. So this is week 11. Week 12, we're going to be focusing on the exam. So we'll probably take one day to try to review chapter 2. And then we'll have the exam. And then going into week 13, we'll do 3-1, probably 3-1 and 6-4. Because I think we have to wrap up shortly thereafter. It looks like I need to go ahead and make a final exam for you guys. Is the exam... And it looks like I need to make exam 3. Oh my goodness. Exam 1, exam 2. So I still need exam 3 right there, and I need the final. I think I'm going to actually go ahead and make these now. Let me go ahead and answer this question. So it was a request for number 1 from this week. Let me do it like this. Number 1. Use synthetic division to find the quotient and remainder. Oh, okay. Synthetic. Okay. So I'm going to do synthetic and polynomial on division. Let me see. Can I see the keyboard? On-screen keyboard? Okay. Can I just like zoom in? I'm going to make the keys bigger. Yes, that's exactly what I want. Awesome. Okay. That looks okay. Let's go back one. Let's look at this because I know you can see it a little bit better. So let me pull a copy. So this is going to be similar to yours, but not the same. Let me scrap that. Oop. Okay, let's try that again. So this one. Okay. I'm going to take that, add a page. You can delete that one. And that one we want to go. Come on, where's my page? There it is. Drop it right there. Okay. So this one is going to be similar to the one that you're working on right here. So let's look at this. And we'll I had planned on already going through this on like Thursday, but since it was requested, we can kind of go through this one. So it asks us to use synthetic division to find the quotient and remainder when the first polynomial is divided by the second. Let's do synthetic division first. Oh, you're doing that thing again? Let's see, I like this. See this? It's okay. So let's do synthetic division first, right? If we're going to do synthetic division, the potential 0 has to go into the chair, right? So if we're dividing by x minus 1, that means 1 goes in the chair. 1 goes in the chair. So then also, before we start writing the coefficients, we need to make sure that every exponent is accounted for. Notice it goes 5, 4, 3, 2, 1, 0. Right, so every exponent is accounted for, so we're okay there. So then the coefficients are 1, 1, -7, 2, -1, and 1. Right? So then the 1 comes down. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. That's going to be what? -5, -5, -3, -3, -4, -4, and the remainder is -3, right? So since we started with the degree 5 polynomial, this depressed equation is now degree 4. So we're going to say x to the 4 plus 2x to the 3rd minus 5x squared minus 3x minus 4. And the remainder is -3. So the quotient should be x to the 4 plus 2x to the third minus 5x squared minus 3x minus 4. And the remainder, let me try in Pearson. I'm just going to do this over here. The quotient, and I guess I can show this, it should be okay. Let's turn this on-screen keyboard off. Let's go with this. Turn it off or automatic. Okay. So the quotient, let's see, so we got x to the power of 4 plus 2x to the power of 3 minus 5x squared minus 3x minus 4. And the remainder we got was negative 3. I think that's okay. All right, we can go ahead and do number 17. Is here. Find all the zeros of the following. Okay, so these can be fun, right? You gotta be ready for these mentally. Honestly, if I was at home, especially if I had like a graphing calculator, I would just. The hardest part is finding that first zero. So I would just type this to the graphing calculator, look at the graph, and that'll tell me where to start. Because the hardest part again for this is just finding that first zero. Okay, let me get a copy. So I want it from here. Oh, that's good. That's good. Okay. Let's just drop it right here. And let's go here. Okay. All right. So we're asked to find the set of rational zeros. Find all rational zeros. So they actually want us to find the zeros of this function, right? So I'm going to start with the rational zero test. I'm going to start with my p over q. Right? So if we do p over q, so the p comes from the factors of 14. So the factors of 14 are 1, 2, 3, 4, 5, 6, 7, right? So then it goes 7 and 14. I think these are all the factors of 14. Divided by the factors of the leading coefficient just happen to be 1. So then ultimately we just get just the top, right? So we didn't have to do the bottom because the leading coefficient was 1. Okay, so then if this function has rational zeros, it's going to be somewhere in this list. I'm just going to start with 1. Let's before we do that, let's do the Descartes rule of signs to see how many, to anticipate how many positive zeros can we anticipate and how many negative zeros can we anticipate, right? So Descartes rule of signs, for the positive zeros, let me see. Descartes rule of signs. Right? Okay. Let's start for the positive zeros. So first we want to test out the positive or possible positive zeros. Okay. So we just count the sign changes from the original. So the original is this. We have this x cubed plus 4x squared minus 19x plus 14, right? So the number of sign changes, let's see, it goes from, there's one there, and then there's a second one there, right? So the number of possible positive zeros we either have 2 positive zeros or 0 positive zeros. Possible positive zeros. Okay. So now for the negative zeros, for the possible negative zeros, we evaluate f of negative x. So we're going to do f of First, I'm going to replace each x with a blank set of parentheses. Okay. And then into the blank parentheses, we're going to do negative x. Negative x. All right. And let's simplify it. So then we'll get the following. We get negative x cubed. It's going to be plus 4x squared plus 19x plus 14. Okay. So then the possible number of negative zeros, we only have one sign change. So there's only one possible negative 0. Okay. Let's see the time. Okay. So as we kind of go through this list, if we find one negative 0, then we can stop. All right. So now we want to do synthetic division. 3, 2, 1, 0. Okay. So let's test out 1 first. So if we put 1 in the chair, and the original, the coefficients are 1, 4, negative 19, and 14. Oops. Okay. So then the 1 comes down. 1 times 1 is 1. 4 plus 1 is 5. That's a 5. That's negative 14. That's negative 14. Oh, God is good. All the time. Because I'm telling you, that first 0 could be a pain to try to find. Like if you don't get it in the first couple of attempts to doing synthetic division, it can be a pain. Then I'm just going to like hop over to the calculator and just look at the answer. Okay, but we got fortunate. So we got our first 0 off the rip. So now, since we started with the degree 3 polynomial, let me make sure I chose the right one. 1, 4, negative 19, and 14. Okay. So now, we started with the degree 3 polynomial. At this stage, we now have a degree 2. So it's going to be x squared plus 5x minus 14. So let's write out what we have. If 1 is a 0, that means x minus 1 is a factor. Uh-oh. And we have this x squared plus 5x minus 14. Again, we're setting this equal to 0. So now we want to factor out that quadratic. Maybe we can jump straight to this thing. The double parentheses. X minus 1 just comes down. That comes down. We're looking for two numbers that multiply to give us negative 14 and add to give us 5. 7 and negative 2. That sounds good, right? So if we do a positive 7 and a negative 2. Notice that 7 times negative 2 is indeed negative 14. 7 plus negative 2 is indeed 5. Right? So those are the two numbers. So this should be the completely factored form. So now we're ready to find the zeros. All the zeros, okay? So then the zeros are now x equals 1, negative 7, and 2. Okay? So then, one other thing. It's a little bit small. I'm trying to see the original. Okay, so we want to plug these zeros into the original function to confirm whether or not they work. But let me pull up my calculator. Okay. So now I'm going to go to my, let me clear this out. Let me go to my y equals. Clear that out as well. We got this x cubed plus 4x squared minus 19x plus 14. Okay? I'm going to quit. I want to call on the function that I just inserted. When x is 1, we should get 0. Okay? When x is negative 7, we should get 0. And when x is 2, we Get you to 0. Okay, so we confirm those zeros. So then I'm going to hop back over to Pearson. This one. Okay, it still looks healthy. All right. So the set of rational zeros. The set of rational zeros. Okay, so let's see. We got 1, -7, and 2. We cross our fingers. Awesome sauce. Let me see the time. Okay. If y'all wanted to go through more, I really want to save this for Thursday, but I think these seem like they take a long time. So if you want to go through another one, we can. Otherwise, I'm gonna kind of go into like some factoring things. Okay. So with factoring, let's do the following. Okay. That's fine. Yeah, we got tutoring information. These notes are like, you're the only class that got this information on the tutoring as well, like this paper. Okay, I am looking for this guy, so let's hop over here. Come on. This. Okay, so I want to go here. Can I just share? No, cancel. Open this up. I want to share. Notability. Add to this one. Import. Okay. And let's go view single page. Okay. So this is a summary of basically factoring scenarios that we'll come across. So whenever we have to factor, this is our train of thought, right? These are the questions that we want to ask ourselves. The first question we want to ask ourselves, is there a greatest common factor? All right, so if we're trying to factor, we ask ourselves, is there a greatest common factor? If there is a greatest common factor, then factor it out, all right? And then once you're done with the greatest common factor, next we typically have one of 3 cases. We next ask ourselves, how many terms are we working with? Are we working with 2 terms? Are we working with 3 terms? Or are we working with 4 terms, right? Terms are things that are added and subtracted. Factors are things that are multiplied or divided, right? So we ask ourselves, how many terms are we trying to factor, right? If we have 2 terms, then we have these cases over here, right? It's typically either difference of squares, difference of cubes, or sum of cubes, right? And so in our factoring section, let me show you how to access this, right? So if you go to Blackboard, our Blackboard page, as soon as you log in, at the very bottom, folder number 7, it says box when. I hate to suppress. Let me go like this. Because if I suppress it, it's going to act up. But if I do this, it'll be fine. Right? So when you click on that box link, it should take you to something that looks similar to this. So this handout that I'm pulling is coming from folder number 5 in this link. Right? So if you open it up, you see there's a whole chapter devoted to factoring, and the summary, we're actually going through the summary right now. And then we'll start kind of making our way through the chapter with whatever time we have remaining. Okay. So if we have 2 terms, again, it's usually one of these 3: difference of squares, difference of cubes, or sum of cubes. Right. If we have 3 terms, you've seen me do this one several times. I'll call it either the AC method of factoring, or if you ever see me do this technique called the box method, I'm usually factoring the trinomial. Usually whenever I have a quadratic trinomial, I just use the same technique every time. The AC method and box is essentially the same thing. There are some other ones, but to me that's information overload. So whenever I have a quadratic, I start off with the AC method, and then I try to go from there. Okay? And then if we have 4 terms, we want to use factor by grouping. I want to say that you saw me do an example of factor by grouping earlier. There was one where I split it into, like, the 8 I split into 1 and 9. I think it was like -1 and +9. Then I started to do factor by grouping, right? So we got this. Let me see the time. Okay. So then after one of those three cases, then it says, how do we know? Sorry. At the bottom it says how. Let me try this one more time. How do we know when we're finished? Look at the exponent. If it's 2 or higher, then we have to go through the list again and keep trying. If the exponent is down to 1, it can only have a GCF or be a factor by grouping problem. Right? So, yeah. So this is a summary. Like basically whenever we're factoring, it usually falls into one of these categories that you see on the screen. So then the other thing that I wanted to kind of look at. So again, if we open up a box link, the box link from our Blackboard page and go to folder number 5, it'll bring us to something like this. We just went through the how to approach a factoring summary. So then we have this entire chapter devoted to factoring. Right? So when I was in grad school and I first started teaching college students, I just thought this was a very comprehensive chapter on factoring. So I just went on and made a copy of it. I just like scanned it. And so you can see, like in this chapter, like in section 6.1, it goes through greatest common factoring and factoring by grouping, right? So it's similar to what the chart that we just had showed. Section 6.2 is factoring trinomials. I typically just do the AC method every time. If it's especially if it's like a quadratic, I just start with the AC method, and that takes care of most of the trinomials. Not all of them, but most of them. And then we have some special factoring. So, just again, we'll just kind of use this as a filler, but it's very good information. Like, and oftentimes students, especially when we have labs and things like this, oftentimes the students struggle with factoring. Even advanced students, most students typically struggle with factoring. So I just thought this was something very important to have. So let's start with this. Let me get a copy of this. All right, let's go here. I know the answers are there, but let's see how to arrive to those conclusions. So we can get this to boot up. And I'm not going to keep you much longer. Maybe give me like right at 5 minutes. Like 5 minutes, and I think we'll be good. Uh-oh. Let's see. I need my documents back. Shoot. What's this? Well, fortunately, this happened at the end of class. So on my end, my notes, they're not gone. It's just like booting. So it usually takes a little while for them to like repopulate back. I'm gonna give it like a minute or two. If it doesn't like populate back, then I'm gonna just let you guys go. Because we're pretty much there. I was trying to be a little bit quick. Okay, so I'm gonna have to let this load. Again, fortunately, this like happened at the end of class, so it didn't disrupt our class. So I'm really thankful for that. But with that technical difficulty ensuing, I'm going to go ahead and let you guys go. If there are any burning questions, I'm going to have to let it load before I can share it. If there are any burning questions, I'm going to let you guys go. We'll meet back on Thursday at same time, same place. Okay, guys? Enjoy the rest of your day. See you Thursday. God willing. Thank you for being awesome.